During the first order system, something like this, where the denominator is, let me use some constant, some generic value. Let us use some values here, right? So let me say it is s plus 5 and denominator is s plus 8, right? Something of this sort. Right? So this is my system. This is 5. Right? And I wish to find the unit step response of the system. So the input is, as soon as I say that I wish to find the unit step response, that means that is is equal to 1 by s, right? So what will be the output of the system or the response of the system? What will it be? It will be nothing but gs multiplied by is, right? From the definition of gs itself, right? So therefore the output of the system will be equal to 1 by s multiplied by this. So this will be equal to s plus 5 upon s times s plus 8, right? This is the output of the system. Now I wish to find the response. What I mean by response is I wish to find the time response of the system in time domain, right? So first of all, what are the system poles? The poles to the system is at s equal to minus 8, right? And because of the input I have multiplied, that is also causing a pole at s equal to 0, right? And what are the system zeros from here? They are at s equal to minus 5, because that is what makes the system equal to 0, isn't it? Okay, we'll just now see how these two things are quite important, right? So if I want to find the response of the system, I need to take the inverse Laplace transform on both the sides. So I'll find the OS, I'll find OT, right? If I take inverse Laplace transform on both the sides. But how would I do that? For that, I'll have to take the partial fraction of this thing, right? So s plus 5 upon s times s plus 8, I can write this to be equal to a upon s plus b upon s plus 8. You know the method of finding a and b? It is simply that I'll cross multiply, right? Then I can multiply both sides by this denominator. So this will be s plus 5 is equal to a times s plus 8 plus b times s, isn't it? Now this expression has to be valid for all values of s. So let me first put s equal to minus of 8, right? So as soon as I put s equals to minus of 8, what happens? This will be minus 3 is equal to, this goes to 0, this becomes minus 8b, which implies that b has to be equal to 3 by 8. Again, the same logic, if this has to be valid for all values of s, so it should also be valid for s equal to 0, right? So what happens? 5 should be equal to 8a, and this goes to 0, which implies a is equal to 5 by 8, right? I hope my algebra is correct. Then the system, the output can be written as, OS can now be written as, from here, it is 5 by 8 upon s plus 3 by 8 upon s plus 8. This is the output in the Laplace domain, right? So how do I now find the output in the time domain? I take the inverse Laplace. Now it's easy to take inverse Laplace, right? So I will write it again so that you are able to have a ready reference, that OS was equal to 5 by 8s plus 3 by 8 s plus 8, right? So now I take inverse Laplace transform of OS, which would give me OT, which is equal to inverse Laplace of this 5 by 8 by s plus 3 by 8 upon s plus 8, right? And this is equal to, so 5 by 8 is a constant, so it will just come out like this, right? What is inverse Laplace of 1 by s? Well, inverse Laplace of 1 by s is unit step function, so that is just 1, right? Plus again 3 by 8 is a constant, so it will come out 1 upon s plus 8. So 1 upon s plus 8, I'll use the property that s has been replaced by s plus 8. So I'll take out e to the power minus 8t. Then I can treat it as 1 by s, and again 1 by s is unit step function. So this will be my OT, right? If you are having problems in doing inverse Laplace, then you should refer your some mathematics book. But I think this is pretty straightforward, right? We have done all the properties. If you have any doubts, you can in fact go back to that Laplace transform video, and you will get how I have found. The property that I have used here is that Laplace transform of Laplace transform of e to the power at ft is equal to f of s plus a, right? This property I have used here. So when I take inverse Laplace, I can, right? Okay, so this is my response of the system. Okay, I should at this point also draw the poles and zero on a complex plane, right? This is my complex plane. This is the real axis and this is the imaginary axis, right? So the system poles were at 0 and at minus 8, and system 0 was at minus 5, right? System pole zeros was at minus 5, right? Now how would the system response look like? Okay. It's a unit step response. Okay. I think this video is already long, so we'll analyze that in the next video.